physics tutorials. I am Dane Campbell. Do you want more videos like this? Please subscribe to my channel, Menelik1JM, on YouTube. Also, like and share. In today's lesson, I'll be looking at graphs. The objectives for this lesson are: 1. Choose suitable scales for the axes of a graph. 2. Plot a set of values accurately on a graph paper. 3. Draw a line of best fit for a set of plotted values. And 4. Determine the gradient of a straight line graph. Before we look at an actual graph, let's look at the rationale for using graphs. Firstly, a graph can show trends in measurements. Example, when there is a change from a linear to a curved trend. Secondly, its shape can give the relationship between two measured values. For example, is it a directly proportional relationship, or is it an inversely proportional relationship? Thirdly, graphs can be extrapolated in any direction to predict results. And lastly, it shows up systematic errors which are way off. These can then be checked. Also, the best fit reduces random errors, which shows up as a scatter of points about the line. Now, in order to be proficient at drawing your graphs, you need to know your graph paper well. Standard graph paper is like this. It has several squares which are of different sizes. The small square is 2 mm by 2 mm. Next, we have a medium square, which is 1 cm by 1 cm. And lastly, we have the large square, which is 2 cm by 2 cm. These measurements are important when you are doing your scales. Now let's look at how to choose your scales. When choosing a scale, you must ensure that it allows you to draw a graph that occupies the majority of the graph paper, such as that shown in the outline in red. The scale that you choose must also not be awkward. What do we mean by awkward? An awkward scale is like 1 to 3 or 1 to 4. This is so because your graph paper has each centimeter divided into 5 parts. Now, your vertical axis and your horizontal axis are called the y-axis and the x-axis. Now let's say you choose a scale of 1 to 5 on your y-axis. Means that the the origin would be 0. Then 5 for the next interval, which would be 1 centimeter away from the 0. Then 10, then 15, then 20, and so on. So it means that each centimeter on your graph represents 5 units. Okay, now we are going to look at some real results and how to plot them on a graph. So these results are coming from a pendulum experiment. In this case, you are asked to plot a graph of length against time squared and to find the gradient of the graph. So here we have our graph paper. We're going to have a title for our graph. Then we draw our axes. So we have the vertical axis would be labeled length in meters. while the horizontal axis would be labeled t squared in seconds squared. Now, how do we figure out our scales? So for the y-axis, we know that there are 10 centimeters available. So here we start in here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have a maximum value of 0.9 to plot. Now an easy way to figure out the scale is to divide the maximum value by the number of intervals available. Now when we do that, we get 0.09. However, 0.09 would be an awkward number to use. So what we do is to round up that number to the nearest appropriate number, which is 0.1. So we are going to use a scale which says 1 centimeter on the graph is equal to 0.1 meter. The scale for the x-axis can be done similarly. There are 10 centimeters available for a maximum value of 3.76 seconds squared. So again, we divide 3.76 by 10, and we're going to get a value of 0.376, which is also an awkward number to use. So we round up to the nearest appropriate number, and that is 0.5. So the scale for our x-axis would be 1 centimeter is equal to 0.5 seconds squared. So in labeling our axes, we have 0 at the origin, and going on the y-axis first, every centimeter would be 0.1 meters, so we have 0.2 here because this is 2 centimeters away from the 0, and so on. So the next one would be 0.4, then 0.6, then 0.8, and finally 1.00. The labeling for our x-axis now, we have 1, so this is also 2 centimeter away from the 0, and every 1 centimeter is 0.5, so 2 centimeters would be 2 times 0.5, which is 1. So every 2 centimeters we're going up by 1, so the next 2 centimeters will be 2, then 3, then 4, and so on. Now we're going to look at plotting our points. So the first point, we'll have 0.2 and 0.841. Now 0.2 is easily read, it's right here. So 0.2, and we match that to 0.841. We know that 0.8 would be about here. 0.84 is somewhere here. All right. Then we have 0.3 to 1.23. 0.3 on the y-axis would be here. And then 1.23 would be somewhere around here. So we do that for all of the points. 0.4 matches to 1.61. Now 0.4 is on this line. 1.61 is around here. And so we continue like this until we have all our points. So we have all 8 points. Next thing we need to do is to draw a line of best fit. Now to draw a line of best fit, we want to ensure that the line follows the trend of the points, but the line should have equal scatter of the points on both sides. So we want to draw a line that will follow the trend as best as possible, because the points that doesn't fall along the line would somehow be due to large amount of errors depending on how far they are from the line. So in the real case, you're going to use your transparent ruler and line it up alongside the points and see how best you can draw a line that follows the trend and also has equal scatter on both sides. So a line like this would be close enough to a best fit line. So what we see is that it doesn't go through all the points, but it leaves some along the line. And what you can do when you're checking is to check to see if on one side of the line how far the points are, how many spaces from the line you count, add them up, and then do the same for the other side. If they are equal, then you know that you have your best fit line. However, your line must follow the trend of the points. Okay. Now the next thing for us to do is to find the gradient of the graph. Now the gradient is found from this equation where m represents the gradient. So we have y2 minus y1 divided by x2 minus x1. So firstly, we want to draw a triangle. So we are going to use two broken lines to form a triangle with the graph line. So we have one broken line here coming down, and then we have another one going across, and these form a triangle with the graph line. This triangle should be as large as possible. You also want to make sure that the points, that the coordinates are not matching with any points that you use to plot. This is to avoid using points that are not on the line. So here we see that the line doesn't fall on any plotted points here. Neither does it fall on any plotted points here. All right. So what we do is to read the coordinates of these points. So our y2 value would be somewhere there. Our y1 value would be there. x2 value would be there. And our x1 value would be there. So reading those points, we're going to have 0.86 meters for y2. So if we look at this, this is 0.8. We have 0.82, 0.84, 0.86 right here. And then here we have 0.2, 0.22, 0.24 right here. So that's y2 and y1. x2 be here, that's 3.5, and x1 would be, this is 0.5, so you have 0.6, 0.7, 0.8, 0.9. So we are going to do the calculation. 0.86 minus 0.24, and that is divided by 3.50 minus 0.90, leaving us with an answer of 0.24 meter per second squared. So we have meters as the numerator, second squared as the denominator. So when that second squared is inverted, we get second to the minus 2. Alright, so that's how you find your gradient. And that's all for this lesson. Thank you for watching. Please remember to subscribe, like, and share. And for tutoring services in math, biology, chemistry, and physics, please check out my website www.onlinesciencetutor.net. You can follow us on Facebook at CSEC Science Tutor 1, also on Instagram at Online Science Tutor. Thank you again. Look out for more videos.